All right, colleagues, let's begin. Hope you have your coffee or tea ready. Because yeah, it's gonna be it's not gonna be a hectic one, but yeah, let's try to do some justice today. So we're going on to definite integrals, and it's still the process of integration. However, the difference is you'll notice, I'll just sketch for you here that on the integral sign there'll be two two numbers over here, right? Typically they're real numbers. So let's maybe say this is a sine theta d theta. So this is how you know when the top and the bottom of the integral sign have some kind of number. So the top side will represent the upper limit, which I'll explain to you now, and the bottom side is the lower limit. Okay. So the difference between an indefinite integral, case in point yesterday, where we don't have those two things, and a definite integral, what we have currently now, is that it has a defined answer and there is no plus c or constant or arbitrary constant of integration, right? So it's not a general type solution, it's a specific solution. So a definite integral will have an answer. What I mean by that, it'll be either 5, 5.5, 10, 10 pi, 3 pi, 4/25 pi. It'll have a defined answer. So that's the difference between the indefinite and definite, as the word says, definite integral. Okay, so how do we do this? I think the best thing is, let me do one example, and then I'll show you what it looks like. I'll do another one, then I'll let you guys do a few for me, just as a form of practice. So it still involves the same integration techniques, just that now you're going to have to define a value. And it's very important for you to comprehend this problem, because when we find integration areas of curves, it's the concept for it. All right, let me do the first one. So here we have 1 and 3, 2x squared dx. As you recall, it's quite simple. Integrate this plus 1 and then divide by the thing we just added. What you're going to do now, instead of having plus c, you close off you make these square brackets, right? And what you do, you put in the upper bound, the high limit, and the lower limit. So then to obtain that definite answer, you had state, so f of b minus f of a. So what all we have to do is basically substitute b into this equation, or the upper limit, and then we have to subtract the lower limit, right, which is a from this. So I'll do that now. We first said 2, 3 over 3, right? This will be that one. This will be cubed minus, now I'm subtracting the lower limit, which is the f of b. That's going to be 2, 1 cubed over 3. Okay, so in this, the first one will be 18 over here, and this will be 2 over 3, right? So if you say 18 minus 2 over 3, you should get a value of 17 and I believe 17 and 1 1/3. Okay. Did everyone follow me until here? Because
Yes,
I
sir.
don't know. That's the thing that's handy. Makabongwe, you got me?
Yes, sir.
Okay, cool. Oh, I don't know why you said that. Okay. Lori, you got me?
Yes, sir.
Okay,
Um,
cool.
Hi.
Yes, Makabongwe. Yeah.
My
Um,
network is bit buffering. I didn't. Okay, can confess. Where did you get the 3 and 1 after the substitution?
It comes from the limits of the integral sign.
Okay. Oh, okay.
You see, so you're taking the upper bound, which is the 3, the upper limit, minusing the lower one.
Okay.
That's what this explains over here. You see, But this explains, there's my zoom here. Oh, there we go. Once we integrate it, we're substituting b into f of x minus substituting a. So it's always a higher minus a lower one. Is that clear? We're going to do more, don't worry. Is it fine? I think Makabong had a question.
I was gonna ask in the beginning, the 2x squared over 3, where does the 3 come from at the bottom?
Ah, man, come on. We did this yesterday. Are you
I'm
studying?
still trying to grasp it.
No, man. Okay, Makabong, it's fine. So over here, right? So remember this thing? Remember that? So this is the same
Yeah.
as saying, you got me now. So look, keep the constant. You're adding the 2 plus 1 and you're dividing by that over here. You got me, which is 3.
Yeah. Okay.
Yeah,
Yeah. I just need to see the longer version of it.
I
Okay.
see. Yeah. So obviously at some point you do it like, by default because yeah, it becomes easy. Okay, is there anything, and everyone understand the concept of minus in the top one, minus the small one? Okay, let's see. Let's quickly do it. So this one is 4 and 20. And then we have dt over t. Okay. To fret not, it's not difficult. All what this basically is 4 over 20, 1 over t, and it's obviously dt over 1, which basically is 4 over 20, which is 1 over t dt. That's your standard ln, right? So if you integrate this guy, which is all the same thing, that'll be ln t. And remember now, we're dealing with definite integral. We're going to put a 20 and a 4. Then what we have to do is substitute the high limit, ln 20 minus ln 4, right? This is your different integral. And if you find the result of that, you should get 1.61. And obviously, you're going to do this in your calculator. I'm not sure if you guys can put ln in your calculator. Can you guys? You guys know how
Yes.
to do it? Okay.
Yes, sir.
Just checking. Then I'll do number 3. Number 3 is that one. Don't worry, guys. I'll send you both recordings once I'm done with these sessions. So this is an important one. And that's going to be root 1 minus sine squared theta. Okay, d theta. So before I begin, is anyone familiar with the concept of radians? Colleagues, radians. Anyone familiar with that? Simple yes or no will suffice here. Thomas is yes.
No.
No. Okay, that's worrying. Okay. So have you guys seen something like this? I don't know. There's probably part of trigonometry, eh? And all it essentially is at this particular level, and I mean, there's a lot I can say. It's another form of writing. What's the word I'm looking for? Angles. So what pi actually is, if you see pi, it actually equals to 180 degrees, right? Therefore, if you have pi over 2, it will actually be equal to 90 degrees. If you have pi over 3, it will be equal to, what's this thing called? 60 degrees, right? And if you have pi over 4, that'll be equal to 45 degrees. So this is, radians is basically another form to represent an angle. But I'm going to just keep it there for now. So when you're seeing pi over 2, you could also just replace the pi over 2 with 180 degrees. I'm just making you aware. There's another form of writing angles. There's a lot I can say to it. But let me do the integration quickly. So before we integrate this, you should be aware. I'll put 180 degrees here because it's easier. So we're integrating from 0 to 180 degrees. root 1 minus sine. Can anyone just tell me what 1 minus sine squared is?
Cos
Give me-
squared.
Perfect, exactly. So that's cos squared. So you root
Sorry,
cos
sir.
squared. Yes.
On the place of pi divided by 2, you put 180, eh?
Oh, thank you. Yeah. I know what you're going to tell me is 90. No?
Yes.
Am I right? Yeah. There you go. Thank you, Chief. So it's 90 degrees. Yeah. There you go. Because pi divided by 2 is 90. If pi is 180. Perfect. So then we have root cos squared theta d theta. Obviously, the square root and the square over here will, as we call it, cancel, or the root's exponential. You'll be left with cos theta 90 degrees to d theta. We integrate cos, and if you recall what the integration of cos was, it's going to be sine theta, all right? To 90 degrees and 0. We can just say simply sine 90 minus sine 0. I'm going to draw my quick sine curve here. Sine 0 will be 0, and sine 90 will be 1. So therefore, the answer is 1 minus 0, therefore be 1. Yeah. Anyone happy with that one? Can I give you some to do now?
Yes, sir.
Okay, perfect.
Ever something, sir.
Excuse me, yes. Are you asking a question or am I missing something? Let me just move this down here. Okay. I'll wait on you. So I'm gonna give you some to do now. Some definites. Let's see if you're picking up. Okay. Here we go. Here we go. Try these ones. What I'll do, I'll paste a solution afterwards. No? So here we go. I thought you were gonna do that. Okay. So you know this, yeah. Here we go. Do these two for me. Mhm.
Hold on.
Are you guys winning? All right, guys, we have like, say, 1 minute. How far are you guys? Tuyo, Makabonge, Spolile.
I'm on the second one, sir.
Okay, good. Yes. I recognize you, Siavuya. Look, I'll give it a minute and I'll paste the answers there, no? And if you have issues, and then we can go through it. Always if you're struggling with something, the key thing you must do is always go back to the fundamentals. That is the key. You cannot do advanced things if you don't go back to the fundamentals. And obviously you don't have time, but take your time in understanding those small concepts which eventually feed into bigger concepts. All right. Nearly there. Okay, guys, it's time. I hope you managed to sort that out. I'll paste the answers. Who's got the answers? Who did not get the answers? Just make it big for you. You all get the answers? You can talk to me. I can't see your thumbs and all of those things.
Yes, sir.
Yes. Is there any no's? I'm looking for the no's or in between.
Yes, sir. Yes, sir.
Perfect. Thank you. Anyone else could not get it?
Yeah, I was battling with the B,
Did you manage to get it or must I come in?
but I see now.
Okay, that's good.
I see now.
Okay, I think let's just do one more. And then I'll give you one more to do, and then yeah, we can proceed on to the actual. What is this? Yeah, on to the curves. Yeah, I'm choosing the best of what I think we can choose, but let's do this one. Okay, okay, cool. Let's try this one out. And bear in mind, like I said to you, pi is equal to 180 degrees, right? So always remember that. So what you're going to want to do is obviously convert the radians into degrees in this case. And then, of course, pi will be simply 180 divided by 4, which will consequently give you 45 degrees. So when you're doing a bounce with this one, yeah, you're there. I'll give you guys, this shouldn't take more than a minute, eh? Yeah. What's the answer to this one? You guys winning? Let me try to do this myself. It's a sign. The integral of sine is what again? Who can remind me? It's cos A. Integral of sine is negative cos. Yes. So this will be negative cos x right? And that's equal to 45 degrees on top and 0 degrees. Substitute cos 45 minus negative cos. So can you see we have a negative at play here, right? Also, that's a 0 here, right? Can you guys see that? A negative at play. So what is cos 45? I believe it's 1 over root 2. And cos 0 should be plus 1. You guys confirm? You guys should talk, eh? I can't see your stuff. And we have 1 over root 2. One over root 2 plus 1. There's no fractional form of this. It should be. Okay. What do you guys get? 1.7 or 7, eh? Yeah. We all get 1.7 or 7?
Sorry,
Oh,
sir.
my bad. It's a minus here. It's a minus.
There's a 3 there. I
There's, yeah,
wanted-
the 3 in front of the, it's
Oh.
3 minus
I-
cos
Got
x.
you.
Yes.
Got you.
Yeah.
Okay, you guys are awake. Amazing.
So why are you putting the 3 there?
Isn't it
3
3 supposed to be
It's
the
3
outside and
minus
factorize the
cos.
bracket?
3 minus cos.
Minus, yes.
It's the same thing.
Cos,
You
okay.
you understand what I'm saying to you? 3 minus
but if
cos
you do your
x.
calculation, it's not going to be the same.
This is the same thing as that. Do you know that? That's the same thing. You times in cos by that. I can assure you it's the same thing. Let's
So
quickly see.
yeah.
Okay. Cool. Let's quickly see. Therefore, this is 3. That's going to be 3 over that. And this is obviously also going to be 3 on this side over here. Just remove that. Great. I'm happy to see people are here. Okay, 3. And your answer should be what? What did you guys get? 0.87. You can call it 879, eh? Approximately. Obviously, we round it off. 879. You guys get that? Damari, Heinrich,
No, I
Sibulele.
got minus 5.121
Okay.
because it's minus 3 cos and that one minus outside and it's going to be plus 3 cos.
Yeah, but I'm saying it's
But
minus
I don't
plus.
know why I got that answer and you got a different one.
Okay, let me just have it.
Negative 3 cos 45
I'm doing it again, yeah. I'm also
plus
checking on math.
3
Plus 3 cos 0, right?
cos 0.
Yeah,
Yeah,
0.
it's, yeah.
There we go.
So
Yeah,
why
it's
did you write
9.
3 over square root 2?
because
Because
it's minus 3 times 1 over root 2.
when I put it in my calculator, I got 3 square root 2 over 2.
It's the same thing.
Oh.
You did not know that.
No, sir.
Okay, so square root 2 over 2, no? Right? It's the same as 1 over root 2. You can punch it in your calculator and see. The reason why they do that on the calculator because they rationalize the denominator. Because at the bottom you have a rational number. So all they basically do on a 1 over root 2, it times both sides by square root 2, square root 2. So that becomes root 2.
Two.
If you times a root and a root with the same number in the middle, you
Root
get 2
2.
over there. You got it?
Okay, thank you.
Yeah. So if you type in the calculator, it'll be basically the same thing. Yeah. Okay. So I believe we could all do that. Can I give you one more trick one now?
Okay.
Yeah, and then we can move on. This is all coming from your textbook. Okay, perfect. Try this one. Now remember this one, eh? Has a cos 2x. Not a straight cos, right? It is a 2x over here. So therefore, if you have experience, you'll know what to do with that 2x. All right, let me give you 3 minutes for this one. Then we can move on. Are you guys winning with this one? The integration of this would be the following. It will be sine 2x. If you remember your substitution, it will then be divided by 2. And of course, we have to times the 3 over here. So we can say it's times 3 like that, or 3 over 2 sine 2x, same thing. And this will be pi over 4, or pi over 4 in our case, we will just call it 45 degrees to 0. Can we all get this part at least? You all get that? Okay, just checking. So let me just quickly do this one. So sine 90 basically. 2 minus ish. 3 sine 0. So I got an answer of 3 over 2.
2.
Is
Yes.
that correct?
Yes, sir.
Perfect. You've got this far. Well done. Well done, guys. Colleagues, can we proceed? Was there any questions with this one? Because now we can do areas under the curves. Theo, Damuri, Heinrich, Liteta, Luvuyo, Makapongwe. Can we move? Lori, Aubrey.
Yes, sir.
Okay, perfect.
Yes, sir.
Yeah, okay. So let's move on to the next section, right? So let me just quickly share. Integration is easy, guys. Right? It's easy. Promise you. Yeah, so we're doing areas and the curves. So before I begin this, just remember all the promises you made to your family members after you get the qualification. The car you promised your mother or your father, or the stuff you've promised yourself. So yeah, make sure you, when you come into the section, you have that in mind. Because it's not rough, but I mean, you need to know why you're doing this. Okay, let's move on. So just to make mention of a few applications of integration, or they call it applying the definite integral. What integration is able to do, it's good for determining areas under curves, right? Centroids of plane figures, that's finding centroids, volumes of solid revolutions, depths of pressure, and electric flux, and so on. It also helps us to solve differential equations. This is true when you're doing N6 mathematics, which are used in a variety of fields, such as aerodynamics, climate change and weather patterns, pricing, heat transfer, propulsion, and structural change. So yeah, so very key concept if ever you become an engineer. And I mean, this type of math you typically see at a postgraduate level. I mean, applying the math, you will see it before. But nevertheless, let's quickly see what this is about. So there are three things which they specify you will learn about. The one is the area bounded by a curve, the x and the two limits. The two limits being the upper and lower limit. The curve where the part lies above and part below the axis, that's another aspect. And the area bounded by two curves. So let's try to embark and solve these problems. So I'm not going to mention what's happening here. What integration is about. I can send you a great video by 3 Blue 1 Brown, which articulates the intuition behind how they actually derive the integration. All you need to know is that integration is finding, it's one of its main functions, right? Is to find areas under curves. Okay. So I'm going to show you what that looks like. And here they basically explain what the area one strip is and so on. But I mean, I don't have time for that now. We have to kind of get to what it is. So what is key is that find the area under one curve is simple. As you can see, it looks exactly like a definite integral. A equals the integral of from B to A, right? The upper limit to the lower limit of f of x. That would be any function possible, right? Times d of x. Any function possible, meaning it's a straight line. An exponential, a logarithmic function, sine, cos, trig function, a polynomial, quadratic. You get the idea, right? So I'm going to show you how we actually find areas under curves. No? So let me just go with this example first, and I'll show you. I'll do like at least 3, then I want you guys to maneuver from there. But what's key here is that you're still applying the integration technique. Doesn't change. Okay. So I'm just going to share my OneNote again, and then, yeah. Then we can move. Where is this now? Okay. So obviously, this is sketch the graph of y equals 4 to the power ex. Show the area bounded by the graph, the x-axis, the y-axis, and x equals 3. Show the elementary strip and calculate the area of the shaded part. Now, I'm assuming people are going to tell me they can't sketch graphs. Am I correct? Is it fair for me to say that? Can you guys read wherever you are? Or can you guys sketch graphs?
Yes, sir.
Okay,
I
you
can.
sure? Okay, perfect. Thank you. Anyone else? Okay. So sketching graphs is fairly easy. We have x our input, y or f of x our output. And obviously this can all be done in the calculator very simply, right? F of x in this case is 4 to the power ex. And you want to obviously put up a table of how to do this. I think I'll probably show you. Let me just demonstrate now, but I'll probably show you with functions again. Is that okay? How I do it on the calculator? Is it fine, everyone?
Yes.
Or should I not do it? So it's,
It's fine, sir.
okay, cool. So let me just quickly do that. So I'm going to open my calculator now and show you exactly what it looks like. I'm gonna have to stop sharing this. So what I'm sketching now is that particular function. So let me just share my calculator. Just let me know if you can see it. Here's my calculator.
Yes.
Can you guys see it? Got this one up? Can you guys see it?
Yes, sir.
Perfect.
Yeah,
So
Yes, sir.
you go. Let me see if I remember how to do this. You go mode table, yeah. Number 7. And then you want to put in your respective functions. So that's gonna be 4. Where's my exponential again? Shift here, and then we're gonna put in x. So you can put in alpha x, right? Something like that. So there, that's how now I've declared a function. Now it's equal. G of X is if you want to put in a second graph. This can be useful for intersection points, but in this case, we make G of X equal to 0. So we're going to say where it starts. So what start basically is all the X values you're going to want to start at. So in our case, we'll start at 0, right? And you'll end at maybe, I'll end up 5, right? So what I mean is going 0, 1, 2, 3, 4, 5. So what I'm doing in the calculator now is I'm inputting from 0 to 5 into the y equals 4 to the power ex. So equal step meaning in increments of 1. So it'll go from 0, 1, 2, 3, 4, 5. You can make it half increments and so on, depending on what resolution you want. And you press equal. So if you look at the graph, get the results. These are your actual values, right? So when you input 0, you get 4. When you input 1, you get 10.873. When you input 2, you get 29.556, and so on. 3, you get that much. 4, you get that much. 5, you get that much. Is that fine to everyone?
Yes, sir.
Okay, cool. So that's just generating the graph, and then I'll revert back to our one node. And nowadays, graphing is not a big deal. Most softwares can do it. Myself, I don't draw graphs by hand anymore. I use various software tools, draw functions like Excel and generate equations. But nevertheless, so let me give you a visual representation of what that graph is going to look like. Okay, so let me just do that for you, just so we can all see what it looks like. Now, some of us are visual people. Okay, where are you now? Okay. Oh, I pasted it over here. Here we go. So that's what the graph looks like, right? Obviously, they won't put in all the y values because obviously this is going in the 500s. So what they actually wanted is this over here. And what they mean by the elementary strip was that dx. So if I do this, the area, this is the standard definition, is y times dx. And what this basically is, it's y, with y being this piece over here, y as it's changing, timesing dx, which is that piece, right? Assuming dx is constant. It's a changing dx. I did put up a cute newspaper article, which I found somewhere on Pinterest, explaining what this means. But it's obviously intuition developed. Nevertheless, and what they're asking here, sketch the graph. So shade the area bounded by the graph on the x-axis, key, the y-axis, and x equals 3. So what they're saying is that they want the area from here, right, to there. I mean this over here. What is that area? Okay. So how do we do that? Those values, right? The top value will be 3 and the low value will be 0. So that's the key part. It's exactly the same as your different integral. And it always works like this. In this case, y is equal to 4 to the power ex, like that. And now all we must do is apply integration. And when we integrate this guy, we have 4 e to the power x, doesn't change. And we want to substitute 3 and 0. And if we do that, that's going to be 4 e to the power 3 minus 4 e to the power 0. I'm assuming we all can do it in a calculator. And you subtract the 2, and you should get an answer of around 76.346, I think, units squared. What's key is here to say units squared because you're dealing with an area. All right. Are we happy with this?
Yes, sir.
Yeah, okay. So I'm just explaining to you again. Same as a different integral, and it works the same. So I'll do another one. I'm going with the book, and I'm gonna give you, don't worry, it's a few ones to do. Let me do this one here. Okay. So this one, 6.14. I think I'm gonna do this one, and then I'll give you guys something to do. Sketch the graph y equals x squared, shade the area bounded by the graph, the x-axis, x equals 1 is that. Okay. So if you have some experience, you should know by now that the graph y equals x squared looks like this. There is no y-intercept. And they want you to integrate from 1, x is 1 should be around here, to around x equals 5, which could be around there. So they just want this area here. And what is key, the one from here to, well, let me just call that 1 and then 5. 1 and then 5. They just want from that piece, right? This portion over there, just that. By the way, you can integrate inside there as well. But yeah, let's just keep it simple for now. So how do we do it? Area equals, is it A, is it BA, right? Let me just get the definition right. BA, f of x, dx, right? Our higher part is 5, our lower part is 1. F of x is x squared, dx. Then an integral. So we integrate this guy, that should be x cubed divided by 3. And then we're going to substitute the 5 and the 1. And if you do that, you should get an answer of, the first one will be 41.667, and the second one should be 0.333. And then eventually you'll get an answer of around 41.334 key units squared. We're finding an area. Okay. Are we all content with this? It's a procedure, fairly easy. Is there any questions before I move on? And please ask questions if you're unsure.
I'm
Colleagues,
good.
any questions? So I'm gonna give you one to do now, right? Is that okay? Yeah, so I'm gonna put it here. Let me do it here. Maybe I should give you 2 to do. I think I have. And I'm really breaking down the stuff here, but I mean, I didn't want to move a bit faster than this, but okay. Start to get the concepts in. So I'll put up the graph for you so you can see exactly what it looks like. Okay, that's the graph for you. And again, you can integrate from 0 to 3. You can integrate anywhere along the curve. All depends on the application. So I want you guys to do this one for me. I'll give you guys, say, 3 minutes. Go for it. Move. Yeah. College, are you winning? Can you give me a straight answer? Remember, it's definite. So you have one answer. You can just maybe shout it out. Anyone? Got the answer? Luvuyo, Cleo, Leteta. What did you guys get?
Just 2 minutes. Sir.
Okay, sure. 2 minutes.
I've got 66.
Perfect. Perfect. Anyone else get 66 units squared, eh?
Unit squared.
Yes, sir.
Not tough, eh? Simple. There you go. That's the answer. I'll give the other guys 1 minute and then I'm going to move on. I need to move on. Time is going. Okay. Let me see. Let me just go to the next one. I'm assuming everyone is doing well so far. I'm going to skip that part and we'll do this now. Yeah. Okay. All right. Can we proceed, guys? Can we move on to the next piece?
Yes, sir.
Yeah. So again, you can apply this to any curve, man. It's really not that rough. As long as you understand the concept of integration and definite integrals, you should be fine. So where I want to move to now is areas bounded between two curves. Okay. Yeah. And it's really not that bad. You just have to understand the concept. Let's quickly do that now, and then yeah. Okay. So just to tell you about this part here, this is finding areas above and below an axis. Case in point, something like this. But if you understand the concept of integration, what they're basically doing here, so the question will read, they have a graph and shade the area bounded by the graph. The x-axis is that, show the representative strips and calculate the magnitude of the area. And what they basically want, they want an area from there to there and from there to there. And when we integrate, if you actually look at the integral sign, right? Yeah, they first find the area of the first piece, right? Which is between 3 and 5, if you look at that, which is quite strange. I'm not sure what they're exactly asking for. Oh, so they specify 3. Oh, from 3. And then they want the next area from 5 to 7. So that's what they basically did. So I'm not sure exactly. They shade the area bounded by the graph, the x-axis, x equals 7, x equals 3. Okay, cool. So anyway, that's what they basically done here. Then they added area 1 and area 2 for this kind of stuff. But let's move on to where I want to get to. So this is the area bounded by two curves. Okay. So similar concept. It just works a bit differently. So we revert over here, right? So here they give you one graph e to the power x. They give you another graph of minus x squared plus 6x minus 5, which is a parabola. Then they put them together, right? And what they're actually looking for here is the area where the two graphs intersect, right? What is that particular area over here? So that AB is a limit. That's a point of intersections. So if you know with your functions, you got to make them equal to each other to solve for the exact x values. And what's key to important, and I'm going to say this, I'll say it twice. What you're going to have to do when you integrate, you always must say the top graph minus the bottom graph. I'll say that again. The top graph minus the bottom graph. They are articulated here. They'll say g of x will always be the graph enclosing the bigger area. F of x will be the graph enclosing the smaller area. So what is key when you're doing your integral sign over here, if you have a look, it's always your integration of AB, which is the two limits with the intersect, g of x minus f of x. Okay? Very, very important. So what I'm going to do
Sorry,
now,
sir. Can you explain
yes.
that again, sir? Can you
Excuse
explain
me?
that again?
So I'll come here. So here we have e to the power x. If you want to find a shaded area between 2 points, we know what it is. Okay? If you want to find the shaded area between here, between let's say 1 and 5, it's between that and that. Am I right? Bounded
Yes.
by the curve. Okay. In fact, we could even the reason why I didn't say bounded by the curve here because it extends indefinitely. So let's say you want to find the area. So we put the e to the power x, we put the x squared on, right? So we want to find this piece over here. Are you with me? The first thing we do, we have to first find with the intersect. Is that correct? Right?
Yes.
Yeah, so we find the x values with the intersect. That intersection points, those x values will be our bounds in our integral sign. Because we're going to be integrating from there to there. Are you with me?
Those points are
But now
not given.
excuse me?
Are those points not given? Must we first
Yes,
find the
exactly. They're not given. You got it. For these questions, you see. Yeah. So I'm going to show you. Then what I'm saying, the key is not to say f of x minus g of x. You always take the top graph, right? And you subtract it from the bottom graph. In this case, it will be your integral BA g of x is minus x squared plus 6x minus 5 minus y to the power e of x. And then you apply integration sign. Once you do the integration, then you substitute those values. So that's the procedure and how you're dealing with this. I hope you got it now.
Yes,
So
plus minus.
yeah, so let's take an example. We don't want to talk too much, and then we're gonna actually yeah. Are you guys learning something, or do you guys know this? I'm not sure I'm repeating the same stuff here. You guys know this?
We're learning, sir.
Oh, okay. I'm not sure, man. Yeah. Areas bound. Cool. So let's quickly do that. So of course, let me first put the graph just for the sake of easier. Okay. So remember, this is area bounded by two curves, which is the advanced problem thing. You know what I mean? Of whatever, of the integration aspect. And this is still nothing, honestly, if you're comparing the other maths. So I believe we all can see that now. So the first step, like I said, let me just do this for you. Yeah. And you're going to be doing one immediately now. The key here, the area of the bounded section is going to be B and A. These are the intersection points. And then we're going to have always the top graph minus the bottom graph, right? So my top graph in this case, can you see it's g of x? Can you guys see that there? On top of the curve, you see here? Yeah. That's very important. Minus f of x, right? Every times in this by g of x. Okay. So now we need to find, right? Say the area bounded by the two curves, which is this piece over here. Let me just zoom in a bit. Let me just make him bigger. Right? That two pieces. So if you guys have any experience, you know to find intersection points, you make g of x equal to f of x. I remember this is a big revelation to me back in grade 11. So g of x is equal to x squared, right? You guys agree with me? No, man. This one is not like this. This should be what's on top here? F is g of x. Okay, no, I'm just getting confused here. Okay. G of x is a straight line. No, man, what are they doing here? Can you see how they confuse these two notations here? Can you guys see it? They're calling the parabola f of x. Do you guys see that there? You see there?
Yes.
Yeah, so they made a mistake here. You must go tell them, whoever that person is. That's g of x. And this is what? That's f of x. Okay. So g of x is given as so it's x squared, right? And then we're gonna say f of x is given as 7x minus 10. You bring everything over, x squared minus 7x plus 10, right? That you make this equal to 0. Obviously, it's equal to 0. You just factorize, right? X, and then you have a 5 and a 2. If you use the quadratic formula for this, please, we cannot be friends. Equals equal to 5, and x is equal to 2. Are we happy with this? You understand what I did here? If anyone doesn't show, please ask. So what I did now, I found where this graph intersects with that one, and those values are x equals to 2 and x equals to 5. Is there any uncertainty with this before I move on? I can't see you guys' hands. Let me just see Teams now. Where's Teams? Are we good? Can we move on? Cleo, Dalmarie, Heinrich, Liteta, Luvuyo. Okay,
We
Michael
can
Bonga
start
says yes.
from now, sir.
Okay, fine. If you're unsure, just say something. Let's move on. So now these x and 2, like I told you, those are your bound values. So these are b, and this is a, right? That's fine. So now we integrate. So we know our top is 5, our bottom is 2. What is my g of x? It was x squared. And we're subtracting, what's it again? 7x minus 10. 7x plus 10, so minus 10. Okay. This is so suspicious, man. Okay, no, it's right. So that's right. Anyway, so then we close the brackets. And what do we have here? Standard integration problem. Is it not so? So let's quickly integrate. X cubed over 3. Can we say yes, colleagues? Are we happy with that? Yes or no? Do you agree with my integration there? The next one is going to be 7x squared divided by 2, right? And the last one will be 10x. Close the brackets.
7x.
And we put 5 in. 2. Do you guys see how the concepts have evolved to this point now? Guys are saying nothing, man. It's boring me. Now we're happy with that. Can you guys find for me quickly how many units squared is that bounded area by, if you don't mind? Just do that in a calculator for me, please. I'm going to give you another one now. Let me see here. So what did I get for that? I'm waiting, colleagues. What do you guys get for that one? How many units squared is it? What did you guys get, eh? Minus. You guys get this one here. What is my thing? You should have gotten 20 units squared. Do you all get this one? So you don't scared to say something. Do you all get that?
I did not get to it. This my calculations was wrong. I'm trying to fix it.
Okay, cool. The book could be wrong. It has made many mistakes here. So your first one should be 33.33 apparently. Is that correct? I think my integration is right. Yeah. Okay. So that's fine. Close that one off. You guys can. What I want you guys to do now is this one for me. Okay. So what I'll do for you, and I've used a grafting software. Let me just change this color of the other one so it can so it'll be a bit better for you. I want you to solve this question. So let me just take this and put it aside here. And I'll. Okay, so I'm gonna snippet a graph for you here and paste it here. Okay, so I've sketched this graph on the software, by the way. There you go. You don't have to sketch it, but you must though determine the intersection points. All right, so number one, 7.1, determine intersection points. Sketch the area bounded by the two curves. And then show the representative strip and then calculate the enclosed area. So you guys do 7.1 for me first. And we can call this f of x. Is that fine? And we can call this guy g of x. Is that okay? Same thing. Just two different graphs. Guys, I'm going to give you 2 minutes for this one.
So, but I can't see that now.
What can't you see? This graph.
Is there a new graph or no? Is it the same old one?
What am I showing?
The one we just did now.
It's a new graph. Yeah.
Oh, but we still have the old one on.
Is it? Do I have? Let me just quickly see.
Yes, sir.
What am I showing you guys? Okay, let me just quickly see. Stop sharing. I wonder if I'm sharing the right thing, eh? Guys, if something's not making sense, just tell me in terms of I'm not sharing the right thing. Can you guys see it? Yeah. Oh, was I doing this thing? Where was this one? Let me go here. Yeah, this one. Can you guys see it here? Number 7.
Yes.
Yeah, that's, I don't know what I was sharing. Oh, I was probably sharing the thing there. Oh, okay.
Yeah.
Yeah, you got it?
Yes, sir.
Yeah. So first get the, yeah, this is from the book. This is from the book. Yeah. Sorry about that. And this is the last one for the day. So first get my intersection points. So be quick to solve that one, eh? Cleo, can you organize your answers for us? $7.1.
It's 0 and 4, sir.
Okay, let's confirm. 0 and 4. You sure about that? f of x is what? X minus x squared plus 5x. I can carry over everything to this side. I'll be, what's it? Is it 4? And that's going to be negative 4x, eh? Am I right? Something like this. Let me check my graph here. My graph is bothering me. My graph should intersect at the right points. What's going on? Let me have a look here. I must look at something. So what do we get? Something like this, right? Do we all get this? X is 0 and?
Yes, sir.
And X is?
4.
4. So you've got your bounds there. Okay. I'm just worried about something. It doesn't make sense to me with my graph here. All right. So the next step is obviously they say you have to sketch your graph and all of that, which you don't have to worry about now. However, what you need to do is basically calculate the area now. So I want you to do 7.3. So you have your upper limit and your lower limit bound. So let me just quickly, yeah. So always remember it's a top graph minus a bottom graph. And I think this is where sketching is a big deal. You know what I mean? But in this case, it's going to be your parabola minus your linear graph. Let me see what's going on over here. Something's not making sense. Something's not making sense here, colleagues. Sorry about that. Something is not making sense here. X is 0. Because my intersection point should be exactly close to this. Not seeing how we getting 0 and 4, man. Something much strange here. Coordinate 4 is not even part of the thing. This is very suspicious here. Something doesn't balance here.
Sir,
Yes.
if you look at your second graph, it says minus x squared plus 5x. I think your graph should go at 0 or what? When second
Nah,
one?
it's right, man. It's going down, and it's right. But what I'm
Yes,
saying is, look at the maths here. Because
but the graph.
yeah, I mean, it should cut it around 1 point something here. But why am I getting X? So what this is saying is cutting at 0. And then and I mean y equals x, and I did it in my graphing software. Maybe that is what I did wrong. I don't know, but I'm pretty sure I did the right thing. I'm pretty sure I can see it here. It's just the graph I've drawn in. Y equals goes right through the middle of the axis, so I don't know what's going on, man.
But so
And
now
what? Yes.
I got x as minus 1.941 and minus 1.791.
1.791.
Yes.
Yeah, that looks correct. Now, what did I do here? What did I do here?
Because we factorize the x. If y x is equal to if x is equals to gx, then we got minus x squared plus x minus 5 or what?
Yes, you're right. So,
But then
yes.
I did that part because I didn't factorize. I went x is equal to minus b plus minus the square root of b squared minus 4ac
Okay,
over
yeah.
2a, and that's why I got that answer.
Yeah, those answers are definitely correct. Yeah, but now I'm trying to see. Yeah, okay. But I'm just going to see that is correct. You can see on the graph. Can you see the 1.179 somewhere there? Another one is what? 2 point something, right? Am I right, Amori? 2 point something, negative 2 point something.
1.9 minus
Yeah.
1.941.
So again,
It's
minus
minus 1.941.
1. Okay, that's a bit over here. Okay.
So that
I
don't know.
carry this over. Let me just quickly check this. No, I just have a software to draw the graph. That is what's, if I didn't even see the graph, it would throw me out. But anyway, do 7.3. I just want to check something here. What am I missing? So it's plus x. That comes over. That's minus x. That's x squared minus 4x for sure. That's equal to 0. Nah, this is solid, man. Like x is a common factor. No wonder. But you say if you do this quadratically, you get a different answer. Plus x minus 5x. Let me just make sure. Yeah, I don't know, man. Something's quite strange. Oh. Sorry. Just solve this quadratically. Okay, so what do we get for our x values? What do everyone get? Let me just check. 7. Yeah, all these textbooks, and this is a sample copy. Yeah, I wonder if they fix the stuff. That's what I'm worried about. See 7 point what is it again? 7 point. I'm just checking what they have here. I don't trust stuff in this book. Module 6. 7, what number? 7, eh? Let's carry on with the integration so long. 6.10, number 7. Okay, I have something here. Yeah, so it's 0 and 4, that's what I have. And the graph.
So,
Yeah.
I think it's your second graph, the one that goes down.
I'm looking, man, something doesn't make sense to me, man. Yeah, the second graph isn't right for sure. My plotting, my graph isn't right. I'm looking at it now. But why is not right? And I'm plotting it exactly what it is, unless I use something wrong in my software. So guys, I think it's my graph which is wrong, man. Yeah, that's the problem. My graph is wrong because the way that I know it's wrong is because of the y-intercept, man. But now I don't know. Maybe I must check myself with the software. Let me just quickly see.
Because at
Yeah, but
4,
just carry on. Just carry on. Don't worry about me. I'm just figuring out my thing here. Don't stress. Just want to check something here. Could be just me. Just want to see. Maybe Yeah, I got it right now. I got it right. Don't know what I typed in differently, but I got it right. So it's me. Yeah. Okay. So guys, the graph should look like this. See there? That's the correct graph here. I don't know what I typed in the software. See there? So it is 0 and 4 for sure. Yeah. Are we happy with that, colleagues? So it was me, it wasn't the book, or it was the book. It was me, it was me.
Yes, sir.
Yeah, there we go. That's perfect, yeah. Okay, so we want the area from 0 to 4. Is that clear to everyone?
Yes, sir.
Yeah. I don't know what I typed in the software. I just recently got it. I think I'm gonna just check what I did here. It's probably the way I typed it. Yeah, perfect. Okay, so that's definitely correct.
So the
Intersected.
answer of the area is in minus 9.333 units squared.
No, it's not. Off somewhere. So I'll set up 7.3 for you.
Okay.
If others haven't done it. Area should be equal to 0 and 4. And remember the top graph is that one minus the bottom graph. So it's going to be minus x squared plus 5 minus x. Am I right? Is that correct?
Yes.
Yeah, exactly. And then if you integrate this guy, it's minus x cubed over 3 plus 5x minus x squared over 2. And 4 and 0 will be your bounds. You just got to substitute that. Other colleagues, are you guys here? Black labels is not good for the brain, eh? So I recommend avoiding that. Likewise with Savannah. Leteta is also good. So can you guys just check my answer for me quickly before we close off?
Sorry, sir.
Yes.
Will there be a recording of today's class?
Would you like one?
Please, I'd like to just go over everything again.
No problems. You'll get it, brother.
Thank you very
Yeah.
much.
Yeah. Okay. The prescription is 2 hours a day, no? Just remember that. What answer did we get?
Minus 9.333 units.
No, it's not that, man. Are you sure it's right?
I'm
you
still
will-
getting the same answer.
Are you willing to put money down for it all?
No.
Sir,
Okay. I'm not happy. I like confidence. I don't want to hear about it. I'm doing it now. So obviously the second one is 0, right? Am I right? So we don't need to work on the second one. Are you with me there?
Yes.
Yeah. I'm just checking that suspicious book, which is proved to be right now. So I'm doubting myself all of a sudden. Okay, let me just quickly see. It's cubed here. I'm checking it out on my end. Don't worry. Yes, I heard someone say, sir. Yeah.
yes, do you integrate from the previous? Because I integrated from x squared minus 4x. The final one that you
How
got
do you mean?
before factorization.
No. You must integrate the original functions. You understand what I'm saying to you? This is solely for the purpose of solving for x. You understand what I'm saying to you? To find intersection points, the area bounded by the curve. You got me? You're integrating from there. That is just giving our upper limits, man. That's all. Where was I now? Do not get confused. So it's gonna be 4 squared divided by 2. How many? What did you get again?
Minus 9.333.
Okay. Let me see. Amen. Minus 9. What am I? Okay. Don't worry. I'm nearly there. Yeah, I also got that. Minus 9.333 units squared, right? I don't know what the book has 10.666 units squared for some reason. Not sure exactly what that is about. But wait, if that's 0, that's 0, that's 0. Yeah, I mean, I don't see anything wrong with the integration. Yeah, 5x. Yeah. I'm not exactly
Sir?
sure what's happening there. Yes, but I can easily check that out again. Yeah.
Isn't it 5x? I see that you wrote 5. Isn't it 5x?
Ah, my bad. Yeah, yeah, yeah. Yes, thank you.
Because I'm getting something offside on this one.
Yeah, sorry guys, man. I got thrown off there. Yeah. Sorry, Dalmori, man. My bad, my bad. It is 5x. Remember, it's 5x here. G of x. There's all graphing through me out. Yeah, yeah. So the answer's probably right here. So it's 5x squared over 2. There we go. So it's g of x, which is this over here. I believe minus f of x. Was it f of x minus g of x? What do we call? Yeah. Sorry about that, man. I just got thrown off now. And you should get the right answer.
So what will happen if you just did the g of x first and then the f of x and then minus the 2? The same thing.
Let's try it out, eh? Right?
Maybe it won't be so simple just to put the x in the f of
Let's-
x. Maybe have
Yeah,
a longer one.
it's a fantastic question. Yeah, let's try it out. So remember, it's going to be x, right? Minus now, minus x squared. In life, we must try stuff, man. I don't want to give you the straight answer. Plus x squared plus 5x. Am I right? No, this is negative 5x here. This becomes negative 5x dx. Does this look anything similar to that? No, doesn't at all. And then if you integrate this, you should get x squared over 2 plus x3 over 2, x of 3 over 3, which is, and then here you're going to get minus 5x squared over 2. Which kind of looks the same, but the only difference is that this is negative and these two are positive, right? And I wonder if you might get the same answer. Because they do mean something. Yeah. It might even come out. So yeah, just try it out and see. But the correct answer according to this book should be 10.667 units squared.
Got it.
Is that correct?
But
Is that
can you
more
just
than-
quickly go up there?
Yeah.
Oh, more.
Like more up, like to the question.
Yeah, to the question.
Okay.
Oh, that's why I got it wrong.
The plus 5x.
Yes.
Yeah, it's me. It's not you, it's me. I was wondering why my graph was wrong, man. Yeah. So you can try that out and see what you get. Could we all get 10.667 before I move on?
5x. X squared.
We'll get back to you now. Yes, sir. 10.666.
Perfect, man. Perfect. What is key, colleagues, understanding the concept which I've just presented. That's what's key here. Okay. Yeah. Is there any questions before we move on? Before we close off, sorry. Yeah. Talk.
Yes, sir.
Yes, brother.
But it still gives the same answer. I wanted to know because if you would have just taken it back from there to x squared minus 4x.
You talking about this one here?
I'm putting
The x squared one.
yes as you
This one here.
yes.
Yeah, so you can't use this because the purpose of this is to find interception points. That's it. You're looking where that and that counts, so you can find the area bounded by that two curves over here.
Oh, okay.
Yeah, that's if this was a distance a velocity time graph maybe of two bodies moving in two different ways. So one body is moving at this particular that function with respect, another one's moving with that one. And what this would represent in terms of a practical thing, this arrow would represent the distance traveled, right? Because S equals V times T. This area will basically be the distance when they both travel the same distance during that particular time. And eventually one goes down, one goes up. So that could be one way of looking at this. But is there any questions with this? I just want to show you one more thing, then I'm done. Is there any questions, colleagues, with this? None. Can't say anything. Okay, everyone says Reese is fine. Aubrey, Stefan, Teta. Okay, Michael Bowen says, okay, cool. So I just want to show you something interesting, right? There's a lot of applications with this stuff. I've used them myself. I just want to show you something interesting, right? And I believe you can use this as part of your career, depending on what job you do. You might understand where this comes from. So I'll just I'm Googling this thing, but I'm wondering about something with this thing which sounds suspicious. They're not actually telling me what it is. So I'm going to my Google. You click on that over there. Go to something called Google Earth. Is anyone familiar with Google Earth, colleagues? Who's familiar with Google Earth? Anyone familiar with Google Earth? Can you guys say something?
No, sir. I only would check the map, sir.
Okay. Stefan says yes. Lori knows it. Heinrich, you know it. Marie.
No, sir.
Okay, you might ask why is this guy showing me this? Can someone? Okay, let me just go to one of the things I showed my students some time ago. It's a place in Durban, huh? And check this out. I'll give you two cases here. Let's say you are working in any industry, type of engineering, and you're responsible for bowling a fuel. Maybe you got a tender, right, from your uncle, and you want to bowl maybe a hole around this field, right? Let me show you what Google Earth can do. I'm going to click on this. Oh, sorry, measure. Right? Let me choose this one. I choose my first point. I click on another point. So it's telling me approximately how it's getting this distance. I choose another point. Choose another point. And another point. And I close it off. Obviously, you have to be a bit accurate here. And what I just got here, if you look on this side here, it's giving me the perimeter. It'll tell me how much fencing I might require, approximately. And it tells me how big the plot is as well. Are you guys aware of this?
No, sir. First time I saw this.
Opening your mind up. Now, the reason why I'm showing this is, how does Google calculate that value? You know what I'm trying to say to you? What does it actually use? And it's fairly accurate. I've tried it myself. Is it using integration? I wonder. It's definitely coordinates, because remember, the Earth is a Cartesian plane with the latitude and longitudes, and they're all coordinates. So I'm just letting you know, just asking you. Another application you might use, let's say what I've used, when you put up PV panels on your roof, right? And PV panels have a set area. But I'm showing the basic way of doing it. But let me just quickly show you. But the issue with this, depending on the type of roof, you must be careful, because you can't just do it for a roof like this. So you have to really adjust your areas properly. So this house is a bit tricky to do, because you know the area there. But let me just quickly find another one for you. Yeah, we can actually work with this, and we have. So let's go with a small place here, right? So I want to measure the area. Click on there. Click on there. But there's an issue with this, and you have to develop the math a bit more, because there's a peak most here, so you lose a bit of area. So the total area is around 70.82, but it's not actually true because of that peak. And once we have this area, we can basically predict Obviously, you have to account for that. I'm not going to tell you what we do there. And then eventually you have to take your panel size, whatever size panel you chose. Remember, it's like a 200 watt peak or whatever, 300 watt peak, and then divide by that particular area, and you can actually determine how many panels. You know what I'm saying to you? Can come on the roof. But the key operating point is, how does it get the area? You know what I mean? Is it maths? I wonder. All right, guys, that's it. This is quite interesting. I'll see you guys. I don't know when I'll see you guys again. But yeah, hopefully you learned something today. Yeah. Aubrey, yes.
So if I want to go over this video again, must I just click on the link?
Don't worry. I'm gonna send you the recordings. Don't stress about it.
Thank you very much, sir.
Okay. I'm just gonna stop the recording now. And all the best, guys, with the test. I know we're calling it a chain rule, but I just spend my time making sure I got these concepts through.